Welcome to the stream, early viewers. Welcome to the stream. Welcome to the stream. We wait for the others 10 minutes, then we start. 10 minutes, then we start. We start at 20:40 hours, like we always do. So, yeah, but thank you for being punctual, my two viewers.
You lost?
Why must I be tortured again by all this?
Hello, Joseph. Hello, name free. It's training time, bro. It's training time. Yes, it's training time. Today we're going to the fun part, man. We're going to the fun parts. We're going to the fun parts. Hopefully, it will be a smooth stream. No, not too many bugs. Hopefully, but yeah. The only thing remaining is actually like the training parts. On the training of like CTC models using the NeMo toolkit. Um, it's pretty easy, honestly. Like we won't even write too much code. Maybe now we get bugs, but it's not hard. The hard part was yesterday. We yeah, the data preparation part was the hard part. One, because it took a very long time. Two, because we need to align the data in the format which Nemo expects. Yeah, so today is going to be fun. Today is going to be fun. Today is going to be fun. Joseph, did you like manage to create the data? Also, like if when I was creating the data of stream, I realized that we needed to save the duration as well. So if you created the data, did you like use this notebook? I linked it in my YouTube, and I had updated it before I linked it. So did you manage to like get the data? I mean to prepare the data with the duration? Yeah. bro, Nimfree, did you like manage to like create using? I mean, was this duration in the notebook by the time you were running the notebook? Because like when I was streaming live, we never had this. We only had audio file path and text. But later I realized we need this for NeMo to like align the audio path. I mean the data loader correctly. Yeah. If you have the duration, it's okay. If you have the duration, it's okay. If you don't, I think you have to recreate the data again. But if you have it, it's okay. If you have it, it's okay. Yeah. So yes, sir. It's 2040 already. So a quick recap. Yesterday it was mainly data preparation. We were supposed to do more than data preparation, but it took a long time. You can see like yeah, you need to rerun. But I think you do. I think you do. By the time I was uploading this on YouTube, I feel like I had updated the notebook. But if I had not, my bad. Yeah. But yesterday, so we were creating we're supposed to do more than data preparation, but the data preparation step was taking a long time, man, a very long time. And so we had to postpone the training to today. As you can see, it finished after 15. No, it's supposed to be like 5 hours or something. Yeah, it took like around, okay, maybe 5 hours. I'm not sure because I left it at night and then woke up after it had finished. Yeah. So quick recap, we download if they don't exist in our Google Drive, we download the dataset on Hugging Face, and the dataset is Mozilla Common Voice 17 and only the Swahili related one. Yeah, we create train and valid splits. These are coming from like the the Hugging Face dataset. We don't need to create the validation splits ourselves because the Mozilla team has made it easy for us by providing us with the train and validation sets. Yeah, I don't know about these two. I really am not sure what they mean, but yeah, we have the train and validation which we care about. And then yeah, we create the data sets. Also, we prepare data in the right format to feed to the NeMo toolkit because the NeMo toolkit expects data in a particular way. Like it's an easy way though. It's a JSON, a list of JSONs. Yeah. So create a JSON for each audio with the file path, the duration, and the text. The text is the transcription from the audio, what the audio is saying. Yeah, for example, this audio, this is the text, the transcription. And then we need to, now that we already built this, we don't want to like run it every time we run this notebook. So yeah, and then if they don't exist, that's when we run this like processing. Yeah, and then we yeah, that's all honestly. Now today we go to the training. Today we go to the training, man. The fun part. But before training, we need to create a baseline. Remember, the essence of us like hunting models on Hugging Face, especially baselines, is for us not to start training from scratch. The essence is to improve the baselines, because if you start training from scratch, it will take a really long time to get a good score compared to someone who starts from a baseline and then improves that baseline. So that was the essence. Now we only tested the baseline. If you remember this notebook, we only tested the baseline on the test set, which we submit to Zindi. Now for us to get a leaderboard score, but we also want to see if what is the baseline score for this validation set, right? Yeah. So that each time we run the training notebook, the word error rate is usually printed. When you use NeMo, it is usually printed after each epoch. So you see if the model is actually improving or not. Yeah, because the essence will be to improve the validation score. Yeah, if it's not improving, then maybe we are doing something wrong. So that is the first thing we want to do today. So what we will do is just copy this, the NeMo ASR inference. It won't take a long time, to be honest. It won't take a long time. Yeah, and as it is running, we'll continue writing the training code. Yes. So we just save a copy of this and call it evaluation notebook. Yeah. So we rename this to evaluation. Then I realized we are doing. The reason why it's taking a long time to install, it's because we are installing everything instead of only the ASR utilities. So you can change that all to ASR. We don't need all these. We only need pandas. Yeah, we need these and we need these. Do we need sound file? I don't think so. We don't need this dataset path. Now the dataset path will change to this, the valid dataset. Yeah, so we need to get the parent path. We need to copy these two right here. Yeah, instead of dataset path, you have the parent path. Yeah, just that. And we want, yeah, this is the model we are trying to improve. Yeah, I feel that's it. Then we load the dataset. We only need the validation dataset. So validation is equals to pd.readcsv, and then we load the valid dataset. We created that. So if you don't know where this validation set is coming from, please watch the yesterday's stream or yeah. So I'll start the notebook. Yeah, so this will change to validation. Also, this will change because now it's a data frame. So for a data frame, you start with the column, then the index. So this will also change. It becomes easier now. We only pass in the we only pass in the path. Yeah, and then here for I.
Oh, it's late.
We don't need this anymore. Now we don't need this because the validation set itself has the. We don't need this. Yeah. Because if you look at the validation set, I don't know if so if you look at the validation set, it already has the audio pad, so you don't need to create the audio anymore. So we need to audio paths will be validation audio path that's to list, I hope, or values, and we check the zero index to confirm everything is correct. We don't need this anymore. Actually, yeah. So this is just creating a basic baseline that will help us see if while training, does the model improve this baseline score or not. Then, yeah, we load our model. That's okay. Yeah, we print the test index. We transcribe, get a text. We don't need this part anymore. We need this. We don't need this part anymore. So this will change to validation. Wait. Yeah, so this will be processed transcripts is equals. Yeah, I need to restart this session. Transcripts dot text here, and then we check if it has been processed successfully. Then we just assign this as a column to the validation set. So processed transcripts. Yeah. And then we don't need this anymore. We are not creating a submission. Here, what we need now is calculate the where. Yeah. So like it has finished installing. We need to restart the session for the changes to take place. Yeah. Yep. And now we check the validation. Error, not such file as valid dataset. Please don't tell me. Don't tell me that. Valid datasets, bro. We have it here. The valid dataset. Some content live stream ASR valid datasets. No such file. Oh. What? We have not even. Have we linked the Google Drive yet? Sorry, my bad. From google.colab, import drive.mount. Yeah, we need to link the Google Drive. Welcome to the stream, my 5 viewers. Welcome to the stream. So, what we are doing at the moment, today we are training. Today we are going to do the fun part. Today we are training our first NeMo model. But first we need to we need to know the baseline score before like trying to improve it, so that when the training is going on, we see if it is actually improving or not. Yes. So that should work now. Great. Now we have the validation dataset. And now we want to, so in essence, what we want to do is like assign a new column here, predicted sentences, and then compare this valid. So this will be the actual sentence and the predicted sentence, calculate the word error rate. That will be a baseline score that we aim to improve. Yes, that's the essence of this part. It won't take a long time though. It won't take a long time. Audio part. Yep. Audio part. Okay, I'll stop the. Okay, we did this the other time. So, but for the new people who are here, yeah. So we'll listen to this audio.
Mame naye ukieye Mame naye ukeye.
Okay, this isn't even like very clear to be honest. But yeah, so you're given such an audio, and the goal is to, I mean, predict what the audio is saying. So you predict the text of what the audio is saying. That's basically ASR in a nutshell. Yes. So we go back to our Spotify. Okay, so we now have the audio path, and now we load the model. So remember, for those joining us right now, remember, the essence of us creating the baselines was not to start from the base model. It was to start from those baseline models. So for example, for NeMo models, if you look at the notebook we saw yesterday, this one, you'll realize that the base model they started from was, let me see. Let's see. Yeah. So they started from STTN quad. Yeah, that model. Yeah, they started from this. But when you start from this, it will take you a very long time to get a good score. Remember, we created baselines which score 0.44 with no training. This was just inference, and it was models trained with past Mozilla datasets. So yeah, so you have models that score 0.44, 0.46. So in essence, we want to start from this model and then improve it, and not start from like a base model which has a word error rate of 1. So that's the essence of like this baseline, what we are doing at the moment. Yeah. So you have the test audio, yeah, and we transcribe it, and you get the text. Mama nae okay. Yeah. So that's okay. The audio is not very eloquent, but I feel like this. I mean, this is what the audio was saying. Yeah. Oh. Test index, is it 100? Okay. Yeah. So that's okay. Um. Now we run it on all the audio parts. Let's see. Yeah. So we will not wait for this to finish. Okay, we might wait, but as we wait, we go back to this discussion. So the organizers provided us with a very, very cool repository. I don't know where it was. Was it here? Yeah. Yeah. So here we want. So they had very good functions of calculating the word error rate. Which I want to copy. Where was it? I think I saw it. I think I saw it somewhere. I think I saw it somewhere. Not this one. But you can actually copy these. Let's see. They had another one. I think I saw it. I don't know where I saw it though. But I don't know where I saw it, to be honest. But they had a very good function. Anyways, we go to our AI friend. We go to our AI friend. Wait, is this working? Yeah. So this will take a while actually. So we'll go to the training code as this finishes. Yeah, the training code is not a lot. So generates a function that calculates the word error rates. Okay, Gemini, show me what you got. Show me what you got. Show me what you got. By the way, did you even talk about word error rate? What it is? I think now we will get to. I hope you can see this. Yeah. So word error rate is equals to substitution plus insertion plus deletions divided by the number of words in the reference. So substitution, a word in the reference sentence is replaced with a different word in the predicted sentence. Insertion, a word is present in the predicted sentence that does not appear in the original sentence. Deletion, a word from the original sentence is missing in the predicted one. And then you use this formula. Substitutions plus insertions plus deletions divided by the number of words in the reference. The reference is the original sentence. And then a lower word error rate score indicates a higher accuracy of the model. Yes. So we need to yeah. So we need to have like this GWA. Yeah. So we'll copy this. We'll copy this function. Yeah, as this is continuing to run. Yeah. We need to install this. If you don't want it to be verbose, you can add that flag. Yeah, we don't need this. Also, this should be moved up there after, like, when you're cleaning the data. Yeah, we don't need this. Calculate df with where. Okay. We don't need this. We have our validation set, and the validation has, so it takes in the sentence and predicted sentence. If they are not, then that it gives you a warning. It raises a value error. Yeah. So for us, yes, we have sentence, and we are assigning the predicted transcripts to. Oh yeah, we need to. So we need to change this to predicted sentence, and then install Jira. Then we display this. So as this is continuing to like evaluate, perform inference of the validation sets, we will now go and build the training data sets. The training notebook. So new notebook in Drive. Yes, and now to the fun part. This is what you've been waiting for. Yeah, this is always the fun part. But sometimes if you're faced with bugs, it can disappoint you a lot. Not disappoint you, but demotivate you. Yes, now we need, remember, we have all the data. We don't need to do any data related thing except loading. So what we need is like the pip install NeMo toolkit, and we only need the ASR. Yeah. This right here. Cool. After we install it, the next thing will be dependencies. Load the necessary dependencies. So we import pandas, obviously. Do we need NumPy? Maybe. And then we need NeMo stuff. We need NeMo stuff. We need NeMo style. NeMo ASR. What else do we need? What else do we need? Okay, we'll add them as we go on. Uh, um, yeah. Or I can run two multiple notebooks with GPU. So this uses. We said you're only using consumer GPU. I mean, what everyone has. So we are running only on the normal GPU. I mean, normal Google Colab, not the paid one. But now since this is Google Colab Pro, since this is Google Colab Pro, we can run multiple notebooks with GPU sessions. But if you are still in the normal tier, you cannot run two sessions with GPU. Yeah. So right now I can run both the validation and the training at the same time. So that's the advantage of Google Colab Pro. One of the advantages. Yeah. So we can get. We only want to use the T4, which is available to everyone. Yeah. And then we install, because this always takes a lot of time. We install that. Yeah. I think that's it. Then. Okay, when we need more dependencies, we'll add them as we go on. Shout out to my cousin. 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 It's your dad you're calling a package, bro. Okay. Let's be serious. So here we are loading the datasets. Actually, no. Bro. I need to be serious on the stream. Like, if you're not talking to me about data science or machine learning, please. But anyways, you always make the stream lively, bro. You always make the stream lively. Where were you the past streams, bro? I missed you, man. I missed you. Yeah. So here we need to load it. Actually, not the dataset. Dataset, we need to load the manifest. Remember this manifest we created yesterday? Where are they? No, not this one. This right here, the JSONs in essence. This is what we need to load. Yeah, so not the data frame. Yeah. Also, our good practice. Okay, we want to check one of the manifests. So, we come to our. Wait, has this finished? We need to link our Google Drive. Shout out to my 7 viewers, man. Thank you for joining. For those who are joining late, yeah. Sorry, but we have done a lot already. Yeah. Not a lot though, not a lot. We are just trying to create a baseline here. Yeah, it's still running. So we generate the baseline score, which we'll try to beat during the training. Yeah. Yeah, so I need to restart the session, then link the Google Drive. Yes, link up my Google Drive. Yep, yeah. Then load the necessary dependencies, and then we want to check one of the manifests, how they look. In essence, it's JSON files, but yeah, for the sake of the stream, yeah. And if you are a viewer and you have not followed me, please kindly follow me on Twitch. You're showing me so much love on YouTube, but you also need to bring the energy to Twitch as well. Yeah. So we find our drive, which we started, which we created yesterday. It was called live stream. Live stream, yeah, this one right here. Then we find, you see, we saved the manifest. This manifest, we are interested in okay, both of them, honestly. So train manifest path, valid manifest path. So this is supposed to be training though. Yeah. And for those, yeah. And then we test one. We test one. So with open chain manifest path, read. Since we are only reading, not like writing to it. Yeah, we load the manifest. Actually, no. We only want to see one. Yeah. So chain data is equals to JSON dot loads line for line. Yeah. Thank you AI. Thank you AI. Thank you AI. You don't need this. Like this is only for visualization. Yeah, we need JSON. Yeah. So make sure your data that you have is looking like this. When you print one of them, it should look like this. Yeah, it should have an audio file path where the audio is stored, and the duration as well. The duration is critical. The NeMo toolkit expects duration to better align the data loader. While packing multiple audios, it needs to know which. It needs to know the duration to like align the audio as well. That is what I know. So you have to. And in our yesterday stream, we forgot to like add this, but in the notebook I linked in my YouTube description, it has the duration. And now calculating this duration makes the processing takes a lot of time. So you'll have to like wait for around 3 hours for the training to finish and like 1 hour for the validation. And then you have the transcription, the text itself. Yeah. So right now we load the configurations. These configurations we saw them yesterday on the NeMo training. You'll see that config. Each NeMo model has a config embedded in it, which can be accessed via model.cfg. In general, this is a config that was used to construct the model. So we want to change a few things in that config. For example, set up new data loaders, which we want to set up with our custom data, optimizers, maybe improve the LR or modify the LR, schedulers if you're interested in the schedulers, and even data augmentation. But for now, we will do only basic things like changing the batch size, the training value, the data loader, etc. Yeah, so that's the essence of the config. So we need to load that config. Here, load the configurations. It's not configuration, and then you specify the config path.
We were just being too selfish.
The working directory configs config.yaml. Oh, we need also to import YAML. Yeah. So if this config does not exist, then you need to download it. So if not exist, we need also OS. If not os.path.exist, config path, then download it from the GitHub. Branch is equals to name, and then make that directory if it doesn't exist. And yeah. So we need to, I cannot write it that down. So if you go to the original GitHub that I was using in the previous hackathon, yeah. If you want to get started with Web2Vec in front of us, you can also check the Web2Vec notebook. Yeah, we'll focus on NeMo since it gave us the best baseline score for a while before we get to like Web2Vec. So you have this Web2Vec option as well. What you want to copy is the location of the config. Where is it, man? Where is it? Yeah, this right here. This right here. os.system f widgets, we don't need these. P configs, yeah. So once you download it, we open it. As F, then we load the params. Yeah. Then we print the params, so that's you know. I mean, so that you can see what those configs are. Yeah. No file, not such file or directory, bro. Branch file not found, but it's supposed to download it though. If not OS path exists, it's supposed to download it. Yeah, let's copy that. But bro, I really am not sure this is not working. It should work, but yeah. Come on, I mean, what's the difference? Bro, like, it's supposed to make the directory, no? Like, come on. But anyways, yeah. So you can see now the params. It has the name. This is the base model's name, which is the same as like the NeMo one, which we are avoiding. Yeah, we are avoiding. Where was it? Yeah, but we saw it. We saw it earlier. I don't know where it is, man. Oh, here it is. Yeah, this was the base model. Yeah. So you have also the sample rates. You have things like dropouts. You can also modify the dropouts. I mean, play with this. Today we're not going to play with all of them. You can also change these characters. For example, if you go to this notebook, which I can also link it today. You can also modify the vocabulary, given that Swahili's vocab is different from English. Yeah, you can go to that link and see. Yeah. So there's a lot of things you can tweak here, but we'll tweak only a few though. Only a few. Oh, it also has augmentations, like yeah. Relu, you can change it to Geldu if you are if you want that. I mean, there's a lot you can change. There's a lot you can change. So you go have fun. Go have fun, man. But today on the stream, we are going to keep things very simple. But now you know that you can change more like more things. Yeah. So now we go to modifying those configurations. The data loaders, as we read in the GitHub. Yeah. So an easy way to do this is to specify a dictionary, and then you update the params dict easily instead of like doing it all. I mean, one by one. Yeah. Okay, this was an old repository, bro. Like this was almost 3 years ago. So like most of the things I was doing here were pretty, pretty, pretty noobish, if I might call it that. Yeah. So if you see like some stupid code in the GitHub, just understand I was young. I was very young. This reminds me of the Silicon Valley episode where I mean, Richard Hendricks. Richard Hendricks, like he had bought all the engineers from Holy. Now one of the engineers was like trolling him because he wrote like a brute force approach to sorting. So if you go to my GitHub and see some stupid shit, I have like a stupid code right here. I don't know what I was thinking. I am really not. I need to update this repository. But yeah, I was young. For example, what was I doing here, bro? Like, what was I doing? Bro, what was I doing here, man? What? This is the same thing. Like, I'm accepting. I mean, exception. I'm repeating the same thing, bro. What was I even handling here? But don't judge. I was young. Yeah. Yeah. So actually, don't use this. Don't use this notebook. Use this one I'm creating right now. Yeah. So you can see, like, even here, like I was actually updating one by one. Like for example, these. You don't need to do all this. Like you can modify it all at once using a dictionary. So don't judge. I was young, man. I was very young. And there was no yeah, I was young. So manifest part. It's the one is specified up above here. So train manifest part. This is where like you had the JSONs, the processed JSONs, the batch size, which you want to change. You can modify this if it leads to like auto-fold issues, but yeah, we'll see. Sample rates 16,000. This is data loader specific, like shuffling, etc. Yeah, and you can also specify the number of workers as well. Yeah, I feel like that's okay. And then all you need to do is just call updates. Yeah, params model dot updates. Yes. Now we also want to to change the optimizer as well. For the optimizer, you do it like it. First, let's see which optimizer they are using. Paint original optimizer. params, model, optim. Yeah, so they're using Novograd with an LR of like 0.001. Weight, scheduler, cosine, annealing. You can change all of these honestly, but what I want to change myself is the LR. But yeah, you see where you see where you can change all the cool stuff you want to change of like guiding your training process. But I want to change to the LR. So um, so I'm just going to create a new optimizer. Everything else remains the same, or the only thing I want to update is the learning rates of team. LR, yeah, I just want to change this to like 0.001. Yeah, that's it. But you can change other things. To be honest. You can change like the scheduler. Yeah. I'm not interested in changing all that. Now we can print the new optimizer. So here we assign the new optimizer, and then actually let's print it first and see. New optimizer. Yeah, you can see now the LR has changed from 0.01 to 0.001. Yes. Yeah. And now you can assign it to the new you can assign it to the new optimizer. I think this is the most safe option to make sure that your params is updated with the new changes instead of like printing the optimizer first. Yeah, it's cool now. It's cool. Cool. Imagine that's all. But you can go crazy here. So the other thing is now just setting up the model. Wait. Did we run this? I think we did. No? Yeah, we did. Okay. Here we now set up the model we are using. Set up the model. So we create our ASR model. Did we even specify a config for? We didn't do our custom. We need to like add our custom class here, the one we are used to. Configurations. Yeah, to specify the model we are going to train. Model name is equals to, yeah, so we go back to our first notebook we ran, the baseline one. This was our best, like this is the one which gave me like 0.4481. We want to update this instead of the base model. Remember that the essence of creating baselines is to see which models performs better and then try to improve that model. Noobs, when I was beginner, I just went to like Google, search for like training notebook, how to train for example, if I'm training a CTC model, how to fine tune a CTC model. I go find a good tutorial that fine tunes from the base. But in essence, there are many people who have done this before, meaning they have pushed their models on Hugging Face. Why are you struggling to start from scratch and you can just improve their models, given that they were trained with like past data and now you have new data? So just update this new model with the new data, bro. Yeah, so that that's the essence, and that is the essence of us actually creating this baseline. Still a long way to go. But bro, we can run two notebooks at the same time. So yeah. Let's have fun in this training notebook. Nice. Now you have a we will use the GPU. Don't worry. and then we initialize our class. Cool. ASR model is equals to, yeah, we have done this a million times now. But actually, this is a deprecated way of doing it. So currently they have been abstracted to, yeah, so this was like 3 years ago. Yeah, we don't need to do this anymore. Yeah, we don't need to do that anymore. We call the abstracted class. Nice. ASR model. So we load the override config. No. We don't need this. What? We just need to load the model. Yeah. Yeah. We load the model. Nice. Yeah. So the model has been loaded. Batch size, trim silence, etc. So we also set up the optimization. Nice. With the new updated optimizer. Remember, we modified the learning rates. So we changed that a little bit. Nice. And you can see now the LR has changed successfully. Cool. So you can go crazy. You can change the weight decay if you feel like. The scheduler. Yeah, so neither mark steps were provided to optim.shed, cannot compute effective mark step. Okay, no problem. So we have done that successfully. Now the next thing will be to set up the training, now the data loaders. Set up the data loaders. To be honest, like training this is not so hard. It's not like, it's just like a few lines of code. Yeah, so we have our SR. Yeah. Thank you AI. Guys, embrace AI. Yes, good. Now, if it has loaded successfully, you'll see this like info, like 0 files were filtered, meaning all files are loaded and they are okay. Now to the fun parts. Now. Training. Oh, sorry, not there. To the fun parts now. Let's see some training, guys. Are you excited for the training part? Time. Now we see how long it will take. Number of epochs. Since we are not starting from a base model, we don't want to like fine tune it for many epochs. Maybe 3 or even 2. Yeah. Or even 2. So number of epochs, maybe 3 or 2. Guys, type on the chat how many epochs you want us to to start with as I take a water break. I'll be back like in a minute or 2. Yeah, type in the chat. I see 7 viewers. Every one of you type in the chat how many epochs you want to see. But honestly, we won't see all of them. But anyways, I'm just taking a break.
Oh, yes, I remember that.
So Dick, you want 100, bro? We're not starting from scratch though. You're starting from six is a lot as well. Six is a lot. You'll see why I'm saying that. Yeah, we're not starting. Remember, we are starting from this already fine-tuned model. These I already fine-tuned this model some 2 years, 3 years ago. Yeah. Right now, we just want to update it to the new data. That's all we want. The model is performing well already. Like it's scoring 0.44 already. Yeah, yeah. So yeah, three is okay. Three is okay. Two is okay. One is okay actually. Even one is okay. Yeah. So currently we have 0.4481. Yeah. Yeah. The goal is to beat this. Yeah, but hopefully, yeah, hopefully, guys. Yeah. So we're going to like set it to like 3 or 2, maybe 3. Yeah, three is a good number. And then the trainer. Now, if you look at these, not even these. So the NeMo toolkit uses. Sadiq, I know you are joking. I know you are joking. But then thanks for joining today, bro. You're always busy, and you're one of my number one motivators to start this stream. So shout out to you, man. Thank you for joining. Thank you for joining today, man. I really appreciate it. Yeah, it uses PyTorch Lightning to do the training. Yeah, you can see here. So we need to like import PyTorch Lightning as well. So trainer. Yeah, so we just copy that. Import lightning.pytorch as PTL, and then yeah. Devices, max epochs, accumulate grad batches, enable checkpointing. I mean, we'll copy just everything here. So you need to import that. Trainer is equals to yeah. Max epochs, accelerator, accumulate grad batches. Yeah, so these two right here. Check val every n epoch, every one epoch, not 10. So it will check the validation word error rate after every each epoch. Log every n step. 5? Is 5 good? We'll see. So we need to specify the epochs. Now this we do it in our config. So we specify the accelerator, and the epoch. We were supposed to change. Also, yeah, things like batch size, we also need to specify them on like the configuration. So cfg dot batch size. Num workers. Do we need to specify this in the configuration though? We can also increase the number of workers. But yeah. So here we specify the batch size 12. We specify the epochs and the accelerator. Yeah. Import touch. So this is just dynamic. If you don't have like a GPU, it will train on the CPU. And we can try to print the accelerator to see if we actually have a GPU. Touch is not defined. Okay. Nice. So we have the GPU. Yeah. So hopefully, fingers crossed. Fingers crossed that this works. We don't get bugs. So trainer ASR model. Remember the ASR model? This ASR model. We need to like now set up the trainer. So set trainer and specify the trainer we have just created. And now if this works, device type. Okay, we need to specify. Okay. Okay. So I'll just comment this out. Don't want to think. I'll just set it to CUDA. Yeah. Bro, no errors so far, So now we go to the fun part. Yes! Fingers crossed, guys. Fingers crossed. Fingers crossed. Bro! And we are training. So the reason why I said you don't need many epochs. See, like the model is already good. Like this is the reference, this is the actual sentence, and this is the predicted, man. Like there's no the model is already good, so you don't need to like specify a lot of epochs. See, for example, this, it's actually accurate, like completely accurate. Even the 3 epochs is overkill. So maybe specify 1 epoch or 2. Yeah. Maybe 1 actually. Yeah. Maybe one. Yeah, and we are training now. You can see the GPU RAM is like 11.9 already. So if you get out of memory errors, please change the batch size. Just come here, change the batch size to something like 8. Yeah. So, yes. That's it, but yeah, you can see like the progress now. It's so fun, and you can actually see like the improvement as the model goes on. The model is actually so good, bro. What do you mean, man? Like, what are we even doing? I think we should modify this to 1 epoch. Yeah, 3 is overkill. 3 is overkill, bro. 3 is overkill. Change that to 1 epoch, actually. Yeah. We should change that to 1 epoch. Not there though. Yeah, the beauty of configurations. Change this to 1. 3 is overkill, bro. 3 is overkill. And that's why I wanted to like first check the baseline score. Without any fine tuning. See the word error rate and then compare that word error rate to what we'll get after this epoch ends, for example. And it will honestly, it will take a long time, like 3 hours, bro. 3 hours for 1 epoch. That means for 3 epochs it will take 3 times 3, 9 hours, bro. Yeah. I think we should restart it. Yeah, and change this to 1. But even 1, we won't say the word error rate anyways. Maybe tomorrow. Yeah, maybe tomorrow. But that's it, bro. That's it, guys. Yeah, we are training finally. We are training. So and here we are just doing very basic things. Very basic things. If you go to this tutorial notebook on GitHub on NeMo, you'll see that there's a lot of things to be done. Updating the vocabulary, because right now we are using English vocabulary, but we don't need to do that for this. Maybe if you're starting from scratch, you need to do all this. I'm not sure yet. The most curious will win the competition. Yeah. The most curious will win the competition. Yeah. So like right now it's set to 1 epoch. So yeah, the model is actually so good. What do you mean, bro? Like this is accurate, bro. Now I wonder how this model is performing. If it's getting a word error rate of 0.30 and we have a word error rate of 0.44 and we are seeing like some responses with perfect some responses with perfect alignment. I mean, this must be very, very accurate. I'm not sure what he's using. I'm not really sure. I'm not really sure. Yeah, but yes, guys, that's it. That's it for today. I don't know what else we'll do. We still have time. We still have like 15 minutes. I hope this finishes before that. If it doesn't, I will. Thanks, Joseph. Thanks, Joseph. MLE star. This. Is it this one? Thanks. I'll read more about it. A self-improving machine learning engineering agent that's redefining the limits of artificial intelligence. With a jaw-dropping record of earning gold medals in 36 of Kaggle competition it enters. This system doesn't just compete, it dominates. But what really sets MLista apart isn't. Okay, you see, like when big companies say like, okay, we are getting like 36% of Kaggle gold medals. I feel like this is BS, bro. This is BS because all their models have been trained on the Kaggle past competition write-ups. So, for example, if you go to Kaggle right now, I mean, all the write-ups are present. Like we go to competitions, everything. Let's find one that ended already. For example, these. So all their models have been trained on the like discussion. For example, was the first place. Yeah. Honestly, they can't generalize on new ones. Yeah, so when they say like that is 6% of Kaggle medals, it's because they've been trained on that historical data already. Like for example, maybe that agent has been trained on these, and yeah, so it can easily get a Kaggle gold medal when it reads this discussion. But the real benchmark is let the agent get into like even let the agent get into one Zindi competition. For example, the Barbados one. I feel like most of them will struggle. There's also these called Neo, a machine learning. Yeah, they also had bold. Yeah, they also had bold like they say that they can win I don't know how many Kaggle gold medals, and all the Kaggle grandmasters were calling them for their BS because they just wanted like let these agents get into the active competitions and we'll see. But anyways, um, for me, I don't hate AI. Like I love AI. I use AI in almost everything. Yeah, and if I had a chance, I will build an AI agent to help me in my Zini competitions. Yeah, if I had a chance, yeah, I think I'll do it someday when I'm free. When I'm free. Yeah, this is also a machine learning agent. Save you 1,000 of hours of grunt talk by automating the entire machine learning workflow. It is powered by a system of agents that works in parallel to solve your most urgent and important ML engineering problems. Yeah, guys, to my other 7 viewers, do you have anything to say? I feel like we have finished the stream. Yeah, the model is actually going on so well. Yeah, hopefully it improves the. Actually, we don't. Okay, 1 hour 28. We can't wait all that long though. And even there's like still 30 minutes remaining. I think I'll give you updates on this tomorrow. Thank you too for joining. 7 viewers today. 7 viewers, like they have stayed. until like the end of the stream. Man, I appreciate it a lot. I appreciate it a lot. If you're on the stream, please let me know in the chats you're on the stream. I know Joseph, I know Sadiq, I know Jacqueline, I know Timothy. Timothy, are you there? I think Timothy is here. He's always here. Yeah, I don't know the others. I don't know the others. Yeah, I only know four guys who consistently join the. Oh, Wayne Maranga, Cephas. I mean, bro, and my brother Kid Nuts, and my brother Kid Nuts, and my brother Kid Nuts. Yeah. Yeah, so don't go use the GitHub one. This is outdated, to be honest. That's what I was like. I don't know what I was doing. Yeah, but anyways, use this updated. So tomorrow we'll go on and see how to push the model to Hugging Face. Yeah, how to push the model to Hugging Face. Actually, you can do that right now. Yeah. Um, let's see if we have the time. 9 minutes. 9 minutes. 9 minutes. Will I be able to do that within the 9 minutes? Let's see. Let's see how easy it is. Okay, for now we'll just use this. We'll save the model to our Google Drive, and then tomorrow we save it to Hugging Face. Yeah. So I think yeah. So we'll just save the model to our Google Drive. Actually, yeah. So cfg dot parent path. How should we save it? We save it using the model name. You save it using the model name, cf.model name. Dot replace. And then we add like maybe updated CFG, also the number of epochs, also the learning rate, so that you can experiment with different learning rates, for example, and see which model was which. Yeah. So also here we we need to add the learning rate to the config. So we use the learning rate of 0.001, and yeah. So here as well, we don't like hard code it. We use the configuration to modify it. Yeah, I think that's okay now.
Not so good.
Yeah, and now we can save it using the configuration learning rate. Cool. And then we save it to our Google Drive. Once we save it to our Google Drive, tomorrow we'll see how to push to Hugging Face. So thank you guys so much. I'll only link this notebook once the training has ended. But I realize other people they don't even watch the replays. Now they just go and copy the notebook itself instead of like understanding everything that was going on. So maybe I'll be linking the notebook after like one day. After one day. But anyways, I'll link the notebook anyways. Yeah. So thank you guys for joining the stream. Really appreciate it. I really do appreciate it. See you tomorrow in our last weekly stream. Adios guys. Thank you so much, man. The video will be uploaded on YouTube before midnight. Okay, bye guys, bye guys, bye guys, bye guys, bye guys, bye guys.